Hey everyone! When I was first looking into geometry nodes, I came across this cool piece of artwork by MacLeod on Blender.org. It looks amazing, so I decided to take a look at how it was made, and found it to be quite helpful for figuring out how geometry nodes work. It's a creative combination of geometry nodes, modifiers, and materials. So let's recreate this little hex world. Let's start by creating our base hex object and a grid to instance it on. Hit numpad 5 to enter orthographic perspective, numpad 7 for top view. We don't need the default cube, so select and delete it with X. Shift A, add a circle. Expand this menu and change the vertex count to 6. Right now, our outer hex radius is 1 unit. I want the inner radius to be 1 unit. It just so happens that the outer radius of a hexagon is about 15% larger than the inner radius. So in edit mode, select all with A and scale with S by 1.15. With everything still selected, hit F to fill in this face. It's an n-gon, but it's fine. And with everything still selected, hit E to extrude. Grab with G and move down on the Z axis. I use -10. Tab into object mode. Let's make the shape slightly more interesting to look at with some modifiers. Hit this tab with the little wrench on it. Add a bevel modifier. Increase the segments to 3, which increases how many divisions each beveled angle has. We want the sides of our hex grid to fit together, so we don't want them beveled. These angles are all 60 degrees, so let's increase the angle limit to a number larger than 60, but smaller than 90 so that the top angles are still beveled. Adjust this amount field to a smaller number, and that looks pretty good. Numpad 7 to go back into top view. In object mode, let's move this hex object out of the way a bit. I moved mine on the y-axis by -8. Now let's make the grid that we'll array and instance our hex object on. Shift A, add a plane. Tab into edit mode. We'll want an edge from here to here, so move this plane over on the x-axis by 1. Select and delete these two vertices. I use circle select with C. Select all and rotate by 30 degrees. Tab into object mode, add an array modifier. We're going to eventually instance our hex on every one of the vertices in this array, so change the x offset to 2. Add a second array and switch its x offset to 0 and its y offset to 2. Increase the count on each of these arrays a bit. I went with 10 and 6 to start with. Collapse these array modifiers. I want to show real quick why the vertices are arranged like this. Add a geometry node modifier. Change this bottom area into the geometry node editor. Instancing an object on another object's vertices is incredibly simple. Shift A, add a point instance node. This is easier with named objects, so I'm gonna do that real quick. Select this field and choose our hex object. If we tab into edit mode, you can see how this is working. It's a pretty creative way to quickly get every other row to offset. And if we change our array size, the hex grid will automatically expand. Let's add some interest to our terrain with a displace modifier. Switch the direction to Z. Click new to create a new texture and drop the mid-level to 0. Switch to the texture tab and change the type over to clouds. This actually looks pretty cool, but it's not quite what we're going for. Switch back to the modifier tab and move the displace above the geometry node modifier. This way we displace the array's vertices and not the post-geometry node vertices. Switch back to the texture tab, and let's adjust these settings until our little hex world looks how we want. If you've watched some of our material node videos, you're probably familiar with what's happening here. This texture is displacing our geometry based on the texture color. So anywhere that the texture is black, the hex pieces will stay put, and anywhere the texture is white will raise up 1 unit, and then everything in between. Let's adjust these settings until we have a decent amount of black on our texture, since black areas are going to be our water tiles. Enable the color ramp here. The alpha value doesn't really matter in this case, but I'm going to change it to 1 to make myself feel better. Add a couple more stops to our gradient. We'll want to see how our scene looks as we adjust things, so switch over to material view, and under render properties, make sure that the render engine is set to Eevee. Turn on ambient occlusion and increase the trace precision. I had some misclicks here and didn't notice, so you can feel free to leave both of these settings on, it's fine either way. Under shadows, increase the shadow resolution to max. And under color management, switch over to standard. Go into the material tab, select the original hex piece and create a new material. Switch the bottom area to the shader editor, and let's create a material that takes into account our instance object's Z location. It's pretty simple. Use the location from an object info node and separate into the X, Y, and Z components. Connect the Z output to a color ramp and that color ramp to the shader color. We'll come back to this material later, but this will show us our hex grid's heights pretty clearly as we adjust things. Select our grid array again and go back into the texture tab. Drop the brightness slightly and increase the contrast a bit. And that's already looking pretty cool. I want to be able to adjust the location and scale of our texture, so let's head back into the modifier tab. In the 3D viewport, hit Shift A and add an empty. Select the array object and switch the displaced texture coordinates to object. Use the empty in this field. Select the empty, hit N, and zero out its location for now. As you move and scale this empty, it'll adjust the displaced texture accordingly. With the empty still selected, scale it way up to zoom in. Grab and move this empty around to see how it affects your grid. Pretty cool. Alright, select the grid object again and go back into the texture tab. If you want to predefine heights that your hex pieces can appear at, we can do all sorts of things with this color ramp. We're going to switch our color ramp's interpolation over to constant eventually, so might as well do it now, and you'll be able to see what's happening better. You can slide these stops around to adjust how much of the image is affected by each height bracket, and you can adjust the color to determine the height of each bracket. The value field in HSV will correspond with the hex heights until we adjust the displace modifier. Leave the first stop black to be the water tiles, and the second stop a very low value gray color to be the beach tiles. Adjust the position and values of the remainder stops however you want. I'm going to try to set mine up close to the original file. Switch back to the modifier tab. Adjusting the strength of the displace modifier will multiply the height values we set in the color ramp, so 2 is a nice round number to use. Let's start setting up our environment material. Select the original hex object and go into the shader editor. Switch the color ramp to constant interpolation. This color ramp functions just like the one on our displaced texture. Adjust the white stop until all the land tiles are white except for the lowest ones. This is when I went to switch my displaced color ramp over to constant interpolation. Back in the material color ramp, adjust this stop to around here to single out the water tiles. The location of our original hex piece doesn't matter, but I'm going to set mine to nice round numbers to make it easier to build and place other objects later on. Switch into render view and let's start making this look more like a scene. Select and delete the default light. Shift A, add a new sunlight. I rotated mine by 45 degrees on the y-axis. You can move it anywhere, since it's the sun, the location doesn't really change anything. Go into our World Properties tab and change the sky color to a nice light blue. Select the hex object and let's start making its material a little more interesting looking. Change this black stop to a blue color for your water tiles. And change this white stop over to a brown color for the ground. Maybe drop the value to make it darker. Right now you can see a little bit of ambient occlusion, but let's make it even more noticeable. Add a mix RGB node here. Switch it to multiply. Add an ambient occlusion node, and connect the color to the bottom socket of the multiply node. Adjusting the factor slider will change the amount of ambient occlusion. I want it set to 1. And also increase the distance a bit. That's starting to look pretty good. Let's quick organize our outliner before it gets too out of control. And let's add a little bit more visual interest to our material. Add a wave texture. In Preferences, Add-ons, make sure Node Wrangler is active. Hit Ctrl-T to add a texture gradient and mapping node. Duplicate this multiply node and drop it here. Connect the wave texture to the bottom input of the multiply node and wait for the material to recompile. Switch from bands to rings and from X to spherical. Drop the factor slider on the multiply node and pick a blend mode. The original file has darkened, so that's what I went with. Increase the distortion a bit. These settings are pretty fun to mess around with if you get a chance. With a wave texture, there isn't much difference between the color and factor output, so you can use either. Connect this factor output to the roughness, which makes part of the material more reflective. To adjust the reflectivity of the dark and light bands separately, add a color ramp and adjust the position and color of each stop. I want the reflectivity of both bands to be more even, so drop the value of the white and raise the value of the black. This looks good to me. Let's add a bit of randomness to our material. Luckily, every object and object instance within Blender comes with a random float value assigned to it. You can access this value through the Object Info node. I'm just making some more room in the material here, and changing my viewport shading settings. Switch back into Rendered View, and add another mix node here. Connect this random socket to the bottom socket on the mix node. Random values are just grayscale colors, so this mix node randomizes the brightness of each hex's color. We're going to use Overlay, which has a slightly different effect, and drop the factor to a low amount. You can add reroute nodes by holding Shift and right-click dragging. To get the appearance to randomize even more, add a Hue Saturation Value node. Drop it here. If you scrub through this hue value, you can see what it does, which looks pretty cool. Connect this random socket to the hue socket. Add a reroute node here, and drop the factor here to a very low number. Now the hue of our tiles are just slightly randomized as well, which makes everything a little more interesting to look at. Now let's add the grass. Select our original hex piece and tab into edit mode. Select the top face and duplicate it. Hit P and choose separate by selection. Select this new object and rename it. Tab into edit mode, select all and go into top view with numpad 7. Scale it down a little bit, select these two vertices and hit J to join them with an edge. Now we're just going to use modifiers to make this into the grass object. It has a bevel already because we copied it from the hex object, so delete that for now. Add a Solidify Modifier, go into wireframe view, and increase the thickness. Add a new bevel, I just left everything set to default. Add a geometry node modifier. We're going to give this object some random shape. Pull this node up into the first node position. Switch over to the geometry node editor. Name this node tree something about grass. Shift A, add a subdivide node, not to be confused with a subdivision surface. This won't actually change the shape of the object, but will divide the faces. We can jump over to wireframe view and see what it does. Add an attribute sample texture node and create a new texture. Go into the texture tab, make sure the new texture is active and switch type to clouds. Increase the size a little, but all the other settings should be good as is. We're going to jump right into attributes. They're pretty cool. Click this field and you'll see a list of built-in attributes. Scale, rotation, and ID don't exist by default, but Blender's nodes know what they represent if you use them as an attribute's name. You can also create custom attributes by using any other name and they'll be automatically created. Let's use position in the mapping field, and create a custom attribute for the result. We can take all those values generated by the texture and save them as any name. I went with grass displays. Let's add an attribute mix node here. Most node inputs can have their type changed. In this situation, we could choose between floats, which are numerical values, or attributes. Let's use an attribute for the factor, specifically this attribute. We're going to take our position, change it by a factor of our grass displays texture, and output the result into the position attribute. And we want to mix the position with the face normals. Our texture is a bit too extreme, so let's tone it down with another node. Add an attribute math node here, use the grass displace in the first field, and as the result. Switch the B input field to float. If you adjust this field, the position changes accordingly. Change from add to multiply and switch to material view. Use a very low value in the math node. In edit mode, select all and shade smooth. Move it up on the Z-axis if anything is clipping. Switch to the shader editor and let's make a grass material. We should name our existing material something and duplicate it. Name this new material grass. We'll delete this node. Select the wave texture and hit Shift S, select a noise texture. Let's change the colors here. Delete the orange stop and change the blue to a light green. Adjust some of these sliders a bit. Change the noise texture nodes, scale, detail, and roughness. And switch the darken node to overlay. We'll come back to this, but for now, select the world array object and go into the geometry node editor. Let's get our grass onto the world. Duplicate this point instance node and put it here. Connect up. Put the grass in the object field. Add a join geometry node and connect up. Select the grass object and go into the shader editor. I'm actually not 100% sure why the color ramp is making some of the grass brown, but that's pretty interesting. Further testing is required. Add another stop and switch it to a darker green color. We want water and shore tiles, and then light and dark grass. So move these stops until there's 3 layers of light green and 2 of dark. Now let's get rid of all this algae covering up our water. Select the world and go into the geometry node editor. We need to separate our points into 2 groups, one that gets grass and one that doesn't. Add a point separate node. We want to place our grass based on Z location, so add an attribute separate XYZ node. The vector we're going to separate is the object position. This node is kinda small, but the full fields read result X, Y, and Z. Select the final field and choose a name for our Z location. I went with height. We need to compare our height to a number of our choosing to decide where to put the grass. So I added an attribute compare node. We can use the height as both the input and the result, and drop the point separate node on. Our height result will be a boolean number, which is true or false represented as zeros or ones, and then we'll use this height boolean as a mask. Switch to the second geometry output on the point separate node, and this is almost what we want. We still need the shore to not have grass. Switch the B field to float and adjust the value until the shore doesn't have grass. Let's give our grass a little visual interest by randomly rotating it a bit. Move some of these nodes to give yourself some more space to work in. Add a point rotate node. Switch to axis angle. We can manually enter a rotation value, or we can use an attribute to have Blender assign a random value at each instance. So let's use an attribute. Add an attribute randomize node. Create a new attribute, call it something you'll remember. Don't call it rotation because that already exists. Add this new attribute here. Each piece of grass has rotated a random amount between 0 and 1. Change these both to very low values. Alright, back into the shader editor, and let's make some trees. Making trees! Add a 32 vertex circle. Move it out near our hex piece so that we can size it appropriately. Select the grass, hit Shift S and choose Cursor to Selected. Select the circle and hit Shift S, choose Selection to Cursor. In object mode, move it off the hex a bit. In edit mode, scale this circle down. Extrude up a bit and scale down. Select all and shade smooth. Alt select this upper edge loop and duplicate it with Shift D. Move this down and scale it up. Extrude up and scale by 0. Hit Ctrl L to select all linked and duplicate with Shift D. Move up on the Z axis, scale down a little bit. Duplicate again, move up, scale down. Add an edge loop here with Ctrl R. In wireframe mode, hit C to circle select all of these upper vertices and delete them. Select all and merge by distance with M. Select this upper loop, extrude up, scale down, and hit F to fill in with a face. Select and fill in these open holes with faces. Select all and shade smooth. Go into the Modifier tab and add a Bevel Modifier. Increase to 2 segments and adjust the amount. And I think that looks pretty good. In the Material tab, select the ground material, and we'll just use this for the wood color. The trees will always be above where the material changes to water, so we don't need to change it at all. Add a new material slot. Select a vertex on the trunk, hit Ctrl L to select the whole trunk, hit Ctrl I to inverse selection. Put the ground material in the second slot and duplicate it here. Rename it leaves or tree or something, and hit assign. Delete these nodes and change the bottom color on the overlay node to a dark green. If we want to more accurately match the original file, adjust the roughness color ramp's darker color stop a tiny bit. Here's our adorable little tree. Be sure to name it. There are several ways to instance our tree on our hex grid. Select the world object and go into the geometry editor. We want trees to be placed only on the tiles that the grass grows on, so move these nodes off a bit. We're going to use the same mask for the trees. Duplicate this point instance node, connect up like this. Switch the object to tree and connect to the join geometry node. So now we have one tree on every grass tile, which is a little boring looking. If you select the tree and tab into edit mode, select all and move it around, all of the trees move. In the original file, there's a tree array with 2 trees. Then the world tiles randomly spin so the trees are in varied locations. I want to go one step further by creating an object that trees appear on in random locations. With the cursor on our hex grid, add a plane. In wireframe, scale it down to fit inside the hex grid. Hit X and delete only faces. The trees will be placed randomly on these vertices, so move them around a bit. Select the tree's point instance node and find the new object. I guess rename it first. Select the world again, and now switch to the new object. Duplicate this node and place it here. Select the tree object. Now we have 4 trees on every grass hex, but I want to randomize it a bit. Make some room. Add an attribute randomize node. This attribute isn't based on position or anything, so let's just choose a name for it. Tree works. Add an attribute compare node. Compare the attribute tree to a float value, and the result can be called tree. Use 1 as the value for now. Add a point separate node. Use the attribute tree as the mask. So every hex with a tree is rolling a random value between 0 and 1, and if the value in B is greater than it, a tree array appears. So if we drop the B value, the tiles with trees are roughly proportional to the B value. By changing geometry outputs, you can invert your tree's placement. Now let's randomize how many trees appear within each hex. Make some more room. Add the same grouping of nodes as before. We can even use the attribute tree again, since point instancing more or less resets the attributes. Then just set it up exactly the same. Now the trees show up randomly on the locations we've predetermined. Let's make things even more random by rotating the base hex tiles by random 60-degree increments. Here's our hex instance. Add a point rotate node, switch to axis angle, and change the angle to an attribute. Add an attribute randomize node. Create a new attribute called angle. Set the max to 360. Since we're rotating a hex, we want to snap our random value to 60-degree increments. So add an attribute math node here, add the angle attribute here so we can see how our nodes are changing the grid, switch the math node to snap. We want to snap the attribute angle to 60-degree increments, so enter 60 in the B value. We're not using degrees currently, so add another math node. Use 2 radians. Use our angle attribute as the input and result. You can tell by the texturing that the hex tiles now have random rotation. And this is all procedurally generated based on the location and scale of this empty, which is pretty cool. You can make this grid as large as you want. I love how this thing looks. That's basically it. You can add anything else you want to the scene at this point. I did something similar to how we did the trees to put some rocks on the shore. It's super easy to get carried away just adding little details all over. Here's how to get them to spawn on the beach. Come off of the opposite output from the grass and trees. You can randomize which hex gets rocks, the location of the rocks on each hex, etc. Also, with just a single attribute randomize node, you can adjust the scale of your rocks. And you can adjust all of these values to make things more rocky, or have way more trees, whatever you want. Don't forget you can use frame nodes and groups and stuff to organize these node systems however you want. You can put these concepts to use to make all sorts of different scenes. It is a ton of fun to mess around with. Thanks for watching. Hopefully you enjoyed or learned something. Please like, subscribe, and let us know if you have any ideas for future videos. If you'd like to help us grow our channel, share our video. It helps us a ton. Thank you again. Stay safe. I love you all. Goodbye.